Hey guys, so when you're multiplying fractions, what is really cool is you can actually simplify your fractions a bit before you solve them, which makes for much less simplifying in the end. So if we'll look at this example first with there's a little bit smaller numbers. So cross canceling, the cross canceling man, if you will, comes in and looks across the fraction. So in a multiplication symbol, right, we're going to look across and across. So we're going to go 1 and 7. Do they share any common factors? Or if I count by sevens and I count by ones, right, will they share anything? And no, just one, right? So if I count by ones, I'll hit 7, but it's not going to be able to produce it all. So no simplifying there. If we go the other way across, cross canceling man goes this way. We say 3 and 3. Do they share any common factors? Well, yeah, 3, right? So we can say, oh, well, 3 divided by 3 gets us 1 and 3 divided by 3 gets us 1. So our new fractions that are smaller that we're going to multiply are going to be 1 over 1 and 1 over 7. So then when we go to multiply, we'll be able to just go straight across. 1 times 1 is 1, and 1 times 7 is 7. You can get the same answer, right, by multiplying without cross canceling. But again, you'll have much more simplifying to do in the end, and oftentimes with much bigger and sort of uglier numbers. So we'll go here in this sort of pinkish color next. So we'll go across. Whoop. Ooh, well, I know I can divide each of these numbers. They're both even, so I know I can divide them by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. And we look the other way. 10 and 7. Well, they don't have any common factors, so I can't do any simplifying there. But all in all, we've reduced these fractions down. We now have 3/10 times 7/4. And when we multiply, we end up with 21, 3 times 7, and 10 times 4 is 40. Right? So much smaller numbers pre-simplified, right? That is pretty cool using cross canceling. Sometimes you'll find that you still need to do a little bit of simplifying after you solve, even when you've used canceling to simplify before you solve, but it'll be much less simplifying to do after the fact. So we're going to do another one up here. So if we look at this little beauty here, we're going to go across and across. So we have 25 and 50. Well, I know that they both share 25 as a factor. So there's 1, 25 divided by 25 is 1, 50 divided by 25 is 2. If I look across this way, we have, I know 9. So 9 divided by 9 is 1, 27 divided by 9 is 3. So check this out. It's gotten so much smaller. 1/3 times 1/2. Whoa, so much smaller, which is awesome. So we have 1 times 1 is 1, and 3 times 2 is 6. So go ahead and try out this last one here, 14/33 times 11/28 on your own, and I'll reveal the answer here in just a minute. So go ahead and pause the video and try it out. So if we look across and across, I know that we can do 7 is a factor of both of these. So 14 divided by 7 is 2, and 28 divided by 7 is 4. When we look across the other direction, 11 is a factor of both. 11 divided by 11 is 1. 33 divided by 11 is 3. So we end up with 2/3 times 1/4. So much friendlier in those numbers. Okay, then we do 2 times 1 is 2. 3 times 4 is 12. And here's an example where it still can be simplified, right? 2 and 12 are both even. So we need to reduce that again. We can divide both by 2. 2 divided by 2 is 1. And 12 divided by 2 is 6. So our final fraction in simplified form is